Good evening, everybody. It is once again Ted the Speed Learner, and I am here once again to present a lesson in Common Core Algebra 2. Now you're going to have to bear with me a little bit because I've had to actually use my other tripod for this specific lesson, and you'll see why as I continue on here. I may have to make a few adjustments throughout the video, so bear with me. Anyway, in this lesson, I'm going to first talk about, or discuss, as the case may be. I know that we should use proper terminology, so I am discussing this right now. I am going to discuss parabolas, specifically vertical stretch and vertical compression. Now, what does that mean? Alright, now watch my fingers. When they come together like this, that's vertical compression. Okay, so if you were going to vertically compress this parabola, you would bring these two sides closer together. Now, if you're going to stretch them out, you're going to stretch them further and further apart. That's vertical stretching. Okay, so now you know the difference between vertical compression and vertical stretching. Okay, it is similarly true about horizontal stretching and horizontal compression. So now you know about vertical stretches, vertical compression, horizontal stretches, horizontal compression. The only thing I don't like about this from Common Core is I feel if they're going to use the word compression, they should use the word decompression. Because decompression is the opposite of compression. But they don't do that, so there you go, there you have it. Alright, now we're going to erase this off. Tonight, we're also going to discuss the quadratic formula. And we're not going to do it the way Common Core does. And that's because Common Core came up with a stupid way to come up with this thing. And we're going to teach it a lot better than that. Okay? Now, what the problem is with Common Core is they're saying, well, quadratic equations are always in the form of parabola. That's not true. That just simply isn't true. Okay? Now, you can plot points using the quadratic equation, the quadratic formula, and you can make a parabola out of it. That is true. But it's not always going to be a parabola. It's not always going to be a hyperbole. It could be something else. Now, for those of you who have been my avid viewers, let me ask you something, and I want you to leave this in the comments below. Okay? I want you to leave this in the comments below, and if you're right, I will, in a future For My Students video, I will acknowledge you, and I will place your comment inside the description of this video. Okay, so, give me just a second here. I want to see if you guys will recognize this. Okay. Now what we got here, I hope I don't have to adjust my camera too much. We're going to have a rectangle here. Just like this. And then I know this is sloppy, but do you guys recognize this? And I'll even draw this line right here just to see if you guys recognize this. Do you guys recognize this? You should. I've covered this on a YouTube video before. Say, wait, what? You're kidding me. I'll even give you a hint. This was drawn by Euclid. Now, can you tell me where he drew this? Now, what is this? This is a representation of the quadratic equation. Oh, no, it's not. Oh, yes, it is. And I covered this in a previous video. Now, hang on. This is a representation of this. Now, bear with me. That's right. That's what it represents. Now you say, well, that kind of looks familiar. It should. Because if you just change it just a little bit, Doesn't that look like a quadratic equation to you? Yep. That's what that is. That is a quadratic equation. And Euclid proved it. Say, oh, come on. You're not going to fool us with this, are you? Yes, I am. Now, Euclid proved the quadratic equation, this particular quadratic equation. He also did another proof. Okay, so this is another, this is one of Euclid's proofs. There's another one in the same area where he also proved another quadratic equation. He proved two of them, at least. There was a couple more he actually proved, but we will get into that later. Now, just because this is the quadratic equation doesn't necessarily mean that he showed us how to make the quadratic formula. Who did that? Well, it was a fellow by the name of Descartes. And yes, I did get some letters in, and they said, you mispronounced Descartes' name. Fine, I mispronounced it. I'm sorry. I'll apologize to the guy the first chance I get. Of course, that would be a little hard since he's 6 feet under, but if I ever meet him again, I'll say, look, I'm sorry I mispronounced your name. Okay, I'm not French. I'm sorry. Anyway, you say, well, how did Descartes geometrically represent the quadratic formula? Okay, glad you asked. Well, I'll now show you how he did that. You see, Descartes published a book called The Geometry. So they go, what? Now this is going to be kind of a crude drawing here. Okay, he did two things. He drew a right angle triangle, just like that. Okay, that's not all he did. Now bear with me. Okay, I know you guys aren't very patient. That's okay. All right. Now, this became the center of a circle. This is its outermost edge. Okay? And right about this point, and all of this is going to be approximate. I could have drawn this out to be a little bit more exact, but I'm not going to tonight. Okay? So, what happened was, he drew a circle and a right angle triangle. And this length are supposed to be exactly the same. And guess what? This length and this length and this length are all supposed to be the same. Why? Because these are 3 radii of this circle. I know this looks more like an ellipse than a circle, but it's kind of a crude drawing. I'm not going to pull out my big compass tonight and draw all this out for you. But you get the general gist. Okay, now he labeled this. That's right, he did. And we have the letter L, the letter N, and he had the letter P here, the letter M here. Okay, so now we got L, N, P, and M, and we have another letter over here, and it's called O. Okay, so we can see all that. That's great. That's fantastic. Now I'm going to pause this video for just a second because I want you to draw this out. You're going to make a perfect circle. It's going to have 3 radii. 1, 2, 3. They're all going to be the same length. Okay? NP is going to be the same length as NO, and NO is going to be the same length as NL. And then I want you to finish it up with a right angle triangle. I know you can do this. So draw this out, because I'm going to make a whole bunch of notes here, and I'm going to erase this diagram to make those notes. So pause this video, draw this out, and when you come back, I'll tell you the rest. I can wait. Alright, that's enough waiting. I know you pause this thing. I know you know how to pause videos. If you're watching this, you know how to pause videos. So, let's erase all this. Now, what do they teach you when it comes to the quadratic formula? They teach you that the standard form of the quadratic formula is the opposite of b plus or minus the square root of b squared. Well, here, let me erase that. Hold it. Let's not do it that way. B squared minus 4ac all over 2a. But they never teach you how to get this. Well, I'm going to teach you. Now, believe it or not, I actually taught you guys how to do this once before. I actually have a set of videos on the quadratic formula on my YouTube channel, and you can look them up anytime you like. Just Google Quadratic Speed Learner and you'll find this. It's right there. But since I know some of you people don't want to go to that kind of effort, we're going to do it again. Now, what is the standard quadratic equation? Well, it's going to be ax squared plus bx plus c equals 0. That is the standard quadratic equation. Now I got to get my notes. Okay, so what's the first thing we're going to go ahead and do? Alright, what we're going to do, and I want you to continue writing this stuff down because I'm going to have to erase periodically due to the limitations I have on this dry erase board. Okay, so periodically I'm going to erase things and you get the idea. Anyway, we're going to isolate some terms. This is a term, this is a term, and this is a term. Okay, that's the first thing we're going to do. We're going to isolate that. Now, the next thing we're going to do is we're going to move that c over to here. Oops. Hold it. Now, how are we going to isolate, or how are we going to move that c over there? Well, I'll tell you how we're going to do that. What we're going to do is we're going to add negative c to positive c. Now, if you add negative 1 to positive 1, what's going to happen? It's going to turn into nothing. Okay? So if you add 5 positive apples to 5 negative apples, well, those apples will just disappear. Period. Okay, so now we know how to do that. Alrighty. Now what's the next thing we're going to do? We're going to take this a out of this equation. Now how are we going to do that? Well, what we're going to do is we're going to do 1 over a times a over 1 x squared plus 1 over a times 1 over 1. No, 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 no. Hold it. My mistake. Okay, what we're going to do is we're going to multiply each one of these coefficients, this one here and this one here, we're going to multiply them, okay, by the reciprocal of this coefficient, the very first coefficient. We are going to multiply this coefficient and this coefficient by the reciprocal of this coefficient. What is the reciprocal of this coefficient? Well, if this coefficient is a over 1, and any time you divide a number by 1, it's going to be itself. 7 divided by 1 is 7. 6 divided by 1 is 6. So on and so forth. The reciprocal of that is going to be 1 over a. Well, if we cross multiply, those go away. So, anyway, what we're going to have left, and hopefully you guys can see this, we're going to have a, the coefficient out here, and that's what we're going to have. Good, you can see all that. Okay, so what we've done was we have extracted a, the coefficient a, out of this whole equation right here. And there you go. And that's why we have b over a. Because b times 1 is b, a times 1 is a. And there you go. Alright. So now we're at this point. Now then, the next thing we want to do is we want to divide both sides of this equation by a. I'm going to show you how to do that. Say goodbye to all that. Okay. So, where are we now? We are here. That's where we are right now. I haven't changed a thing. Alright. Now we're going to divide both sides of this by a. This cancels out that. And now we have this equation. That's what we got now. Alright, now then, they have a little thing here called completing the square. Now, how do we complete the square? Well, we're going to take this coefficient right here. That one right there. We're going to multiply 1/2 times b over a. Okay, so now we have b over 2a. But that's not the end of it. To make the final term here, we have to square this. Okay, so what is b over 2a squared? What is that? Well, I'll show you. Alright. b times b is b squared. That's the first part. Now what is 2a times 2a? Well, that's 4a squared. That's what that is. Okay. Now, where are we going to put this term? Well, I'm going to show you. Because we've got to put this term somewhere. Now then, let's go back. Now if I get time, I will actually do another video describing how you complete the square. But that's the process basically. I would like to give you an illustration. I won't give it in this video, but I'll give it in a different video at some point in the future. Maybe even tonight. I don't know. Anyway. So, you remember that wonderful term that we formulated earlier? We're going to have plus And we're going to add it to both sides. Just like that. Okay. Now the thing is, I don't like it arranged like this. So here's what I'm going to do. I'm going to erase this part of it. Now, at this point, since this denominator is not the same as this denominator, can we subtract these two fractions? No. Well, we're going to fix that. We're going to make a common denominator out of this. It won't happen in just one step, but we are going to make a common denominator out of this. Okay? Alrighty. Now, we have now, what we're going to do is we're basically going to multiply these two terms by some form of 1. Well, what is 1 divided by 1? 1. That's what it is. Okay. Now then, what is A divided by A? Well, A divided by A is 1. Okay. So we're going to take this and we're going to multiply it by now where do we get the A? We got the A from right here. That's where we got the A. Okay? That A is now this. Now then, what is 4a squared divided by 4a squared? Well, that's going to be 1. Now we're going to multiply this times that. Now where do we get the 4a squared? We got it from this denominator right here. So this one's here, and this one is here. And that's how we did it. And that's how we're coming up with this common denominator business. Okay. So what happens when we do this multiplication? And feel free to pause this video at any time to kind of get all the notes, because I know this is going to be kind of confusing. Alright, so we're going to do the left side of the equation. As you can see here, nothing changed on this side. However, what is a times b squared? Well, that's going to be ab squared. What is 4a squared times a? Okay, this is a to the first power. A to the first power plus a to the second power is going to be a to the third power. So now you have 4a to the third power. Okay, so now we have 4a3. Alright. Now what happens when you multiply 4a squared times c? 4a squared c. That's what happens. Now, again, this is being raised to the power of 1. Okay? So 4a squared times a to the first power is going to be 4a to the third. But we don't like it like this. Okay? Looks nice, but we really don't like it like that. So what are we going to do to change all that? Here's what we're going to do. We're going to simplify it. Alright. This has an a to the power of 1. This has an a power to the 3. We're going to cancel that and cancel this. And so now we have b squared over 4a squared. Okay? So in other words, we got rid of this a completely, and we changed this exponent here from 3 to 2. That's all we did. Now, what about this one here? Well, we want this denominator to be exactly the same as this denominator here. Why is that? Because you see this denominator here? This one's going to be the same as this one, and it's also going to be the same as this one. That's why we're doing this. We're going to knock this one power down, one power down. So now we have 4ac divided by 4a squared. That's why we're doing this. Okay. Now then, what is our next step? Well, we're going to use the reversed FOIL method to get rid of this. That's right, we're going to factor this out. What's it going to become? Okay, well, I'll show you what it becomes. Let's get rid of that. Now, if we factor out the left side of that equation, what we're going to get, and like I said, pause the video, write all this stuff down, go through it step by step with me. Okay, now we have x plus b over 2a and if we use the FOIL method to pull this all back out, we'll have the same equation as we did a couple of seconds ago. I'm not kidding you, we will. Alright. Now, we're also going to simplify the right side of the equation. Does this look a little more familiar to you? You say, well, man, that looks kind of familiar. Okay. Now, what's the next step? We're going to square root this, and then we're going to square root this. Now, what's the square root of this? That's easy. Just remove the parentheses and that exponent, and you got it. Just like that. Now, what's the square root of this? Well, we're going to square root the top. Just like that. Now, what is the square root of 4? Well, that's going to be 2. What is the square root of a squared? A. Now, have you noticed something here? The denominator here is exactly the same as the denominator here. That's a good thing. Alright. Let's go through a little bit more here. Now then, what happens if we do this? Couldn't we add all that together? Well, of course, because they have common denominators. Of course we can. So, if we make one final step, now I am going to add a little bit more to it. I'm just going to flourish this out. This should look a lot more like what we want. Does that look familiar to you? Of course it does. That is the standard form of the quadratic formula. That's it. And now you've seen how to do this. Now, why don't I like the way that they do it on other videos? Because they do it too fast. That's why. I'm doing this a lot more slowly so you can pick this up. But we're not done. Now we've got the quadratic formula here. But what about Euclid? I told you that that triangle and that circle represented geometrically the quadratic formula. Now I'm going to show you how he got it. Okay. What he said was, he represented lines. Okay? So, what he ended up doing is he ended up getting an equation How did he get that? Okay. He allowed each one of these letters to represent a line on that drawing. You remember that drawing with the triangle and the circle? Okay, these letters represent those lines. And that's the real trick. So what is line LM? Well, line LM is equal to B. So go back to that drawing of that triangle and that circle. LM equals B, which is the square root of B squared. So if LM squared is going to equal that B squared right there. What about ln? It equals 1/2 of A. So the length of ln is 1/2 of A. But that means that twice the length of ln is going to equal A. Okay. And the whole line OM is equal to Z. That's the length we're looking for. Okay, so OM is Z, and OM squared is Z squared. And this is based on the Pythagorean theorem. Wow! Can anyone tell me where in Euclid he discussed the Pythagorean theorem? If you can, leave the answer down here below. Alright, so now we know what all these letters represent. But this doesn't look like the quadratic formula. Well, gee, we got to make it into the quadratic formula. I don't blame you. Let's do it. Let's get rid of that. Alright, so let's put all the terms on one side. Does that look like a quadratic equation to you? You bet. Alright, so what is the coefficient of this first term? Well, it's going to be 1. So we're going to extract 1 out of Z squared minus a over 1 z plus b squared, which of course equals 0. Okay. So far, so good. Now then, what's next? Well, we want to put this term over here. So now we're going to have 1 z squared minus a over 1 z equal to negative b squared. That's what we're going to have. Alright, now we're going to divide both sides of this equation by 1. So now we're going to have z squared minus a over 1 z equaling negative b squared over 1. And that's what we have. Now we need to complete the square. So what we're going to do is we're going to take this term, this is the coefficient, this is the b coefficient, we're going to multiply it by 1/2. Now what happens when we do this? Well, it becomes a over 2. Now, it's not enough that we have this a over 2, we have to square it. So what is the square of a over 2? Well, it's going to be a squared over 4. That's what it's going to be. So far, so good. But we got to keep going. So, now what are we going to do? Well, we got z squared minus a over 1 z plus a squared over 4, and this is completing the square here, which now equals a squared over 4 minus b squared over 1. Now we want this 4 and this 1 to be the same term. How are we going to do that? Well, what we're going to do is we're going to have z squared minus a over 1 squared plus a squared over 4. Which this is going to equal, let's see, 1 over 1 times a squared over 4. Because of this term is going to end up right here. Okay, this 1 is going to end up right here. Minus 4 over 4 multiplying b squared over 1. Where did we get the 4? The 4 came down here. That's how it happened. You're used to this. So, what do we get next? I know this looks like a 2, but it's z. And that's what you get. Now we have to factor this out. It took me a while to do this, but I got it done. As you can see, the 4 is now the same term, so now we can do this. Okay. Now we're going to square root. What is the square root of 4? Well, it's going to be 2. Okay. Now we're going to put this term on the other side. So now we have a over 2 plus the square root of a squared minus 4b squared divided by 2. Well, we can combine all that together, and what we got left equals a plus and that is the quadratic formula according to Descartes. Every term in here is exactly the way he had it on that circle and that triangle. That's exactly right. So now what you have here is z equals a plus the square root of a squared minus 4b squared divided by 2. So he did come up with the quadratic formula. It's a little hidden, but you've seen it for yourself. That's your quadratic formula. It can be represented by parabolas, it can be represented by hyperbolas, but in the end, the Descartes triangle circle is the true derived quadratic formula. He proved it, he showed it, there's no reason why you couldn't get it. And this is what he created. Okay, so now you know how the quadratic formula came into being. Wow. I know this has been a rather long video. I'm glad you were so patient with me. Whew. Anyway, thank you all for watching. I will answer more questions in Common Core Algebra 2 in a future video, so I would like for you to stay tuned.